All right, so if we're predicting the products of a chemical reaction, okay, our steps go as follows, okay? We want to first write out the reactants, okay? And by that I mean their formulas. Okay, that's my first step. Write out the reactants. That is their formulas. And then these ones I have to do that because that's not given to me. So if I'm looking at number 5 and following my steps, okay, I've got iron 2 sulfide. So that would be FeS plus 2 and minus 2. Okay, reacts with oxygen gas, which I have to remember, well, they reminded me, is a special element, comes as a 2. All right, so there's my first step. I have written out the reactants in formula form. Okay, the next thing I need to do is identify the reaction type. Incidentally, RXN is shorthand for reaction. Okay, so anytime you see me write RXN, it's reaction. Okay, so I need to identify the reaction type. In this, I've got an ionic compound. It's reacting with an element. So what kind of reaction would that be? Okay, Laney, what kind of reaction is that? Single replacement. All right, so I've got a single replacement reaction. Now, the element is a non-metal. So who is it going to replace in this compound? It's going to replace the sulfur, right? It's got to replace the non-metal. So that means sulfur is going to end up alone, and iron is going to end up with oxygen. All right. Now, sorry. So I went ahead here. I identified the reaction type, okay, and then I had to predict, okay, like products, essentially. Once I've predicted the products, then I need to check for some things, okay? I need to check for special elements. And I need to swap and drop ionic compounds. Okay, so that's the step I'm on right now, checking for special elements and swapping and dropping any ionic compounds. Do I have any special elements here? Sulfur, okay? Sulfur always comes as an 8, so that's definitely special, okay? And I have an ionic compound. I have iron with oxygen, and I'm told it's the iron with the 2+ charge. All right, so if this is iron with a 2+, oxygen's always 2-. That compound is already dropped and swapped. It's okay the way I wrote it. All right, now that I've checked everything, what's my last step? Balance the reaction. Okay, it's 5 steps. All right, so I got to balance the reaction. What should I start with? Biggest number. Start with sulfur. All right, I got 8 sulfurs over here, so I need to make sure I have 8 sulfurs on the reactant side. Now I have 8 iron on the reactant side. I need to make sure I have 8 iron on the product side. When I do that, it gives me 8 oxygens, so I need to go back over to the reactants and make sure I have 8 oxygens, and now I do. Okay, so it's always those same 5 steps. Okay, write out the reactants, identify the reaction type, predict the products, okay, check for special elements, swap and drop ionic compounds, balance the reaction. Okay, are you always going to have to drop and swap ionic compounds? You're going to get some reactions like let's say a decomposition reaction where there won't be any compounds. So you won't have to drop and swap, but you'll have to check for special elements. Okay, if you're in a double replacement reaction, you're not going to have any elements by themselves. So you don't have to look for those, but you'll have 2 ionic compounds to drop and swap. Okay, so they're combined into the same step because you usually have to do them both. Okay. All right, I want you guys to continue working on these so that we get practiced up with them. All right, so I'll put the rest of the sheet back up on the board here. Okay, I'd like you to get to at least number 20. Okay, if you get to number 20, then you can start on the next one, which is more reaction practice. Okay, you can also call that up on your phone. And yesterday, remember, I put the key in Google Classroom. So in yesterday's post in the stream will be the PDF file that is the key for all these reaction worksheets. Do 2 or 3 reactions at the most, and then check your answers. Okay? The worst thing you can do is practice doing something wrong, because all that will do is cement it in your mind. Okay? Check your answers, make sure you're getting them right. If you're not, ask. Okay? I will come around and give you some help. Okay? When we're looking at molybdenum, okay, that's MO, right? Yeah, molybdenum's MO. Okay, so we got MO, and it's a +6, I believe, right? Okay, so molybdenum's a +6. Sulfide is a -2. So when I drop and swap this, I get 2 and 6. But what am I supposed to do with an ionic compound if I can? Reduce it down. Okay, so this is actually going to be MOS3 when I reduce it, because it's 2 and 6, and I can divide both of those by 2. Okay, so we're going to have MOS3. We always reduce the drop and swap if we can. All right, that reacts with oxygen gas, which is O2. Okay, what kind of reaction is that? Single replacement. All right, so oxygen has to replace sulfur in this reaction because they're both nonmetals, and the replacement has to be between the things that are alike. So that means sulfur ends up by itself, and molybdenum ends up with oxygen, Mu, with a capital O at the end. Now, it's actually not just going to be Mu, it's going to be Mu3, because this is a +6 and this is a -2. I've got to check for my special elements, which I already did, and I've got to drop and swap and then reduce. It's going to be 2 and 6, just like the other one was, so I'll reduce that down to this. All right, now I've got to balance this reaction. Okay, I've got sulfur that I should probably start with. I've got 8 on one side and 3 on the other. What's the lowest common multiple of 8 and 3? 24. Okay, is the lowest common multiple of 8 and 3. Okay, if I put an 8 here, that will give me 24 sulfurs. Similarly, a 3 here will give me 24 sulfurs. All right, that gives me 8 molybdenum atoms. So I've got to go over here and make sure I have 8 molybdenum atoms. That gives me 24 oxygens, so I need a 12 in front of the oxygen. So that one's pretty tricky. Okay? Tricky balancing, big numbers. Okay? And then obviously that whole reducing the ionic compound thing also plays a role there. Okay? Any other ones we got questions about? Okay, keep going. Okay, so looking at 13 here, we got barium chloride. So that'll be Ba with Cl, and that'll be BaCl2 because barium has a +2 charge, right? Pretty sure it does, yeah. Okay, and then it reacts with ammonium carbonate. Now this one's tricky because that's 2 polyatomic ions joined together. Okay, now ammonium always acts as a metal because it's the only positively charged one we have on our list. Carbonate is a -2. So when we drop and swap this, we need to put brackets around the ammonium so there's a 2 there, okay? Because that 2 has to apply to the whole thing. Now it's just a double replacement reaction where ammonium acts as the metal. All right, so sorry, I'm just going to shift all that over. Whoa. Come on, over here. Okay, so now what I'm going to end up with on the other side is ammonium with chlorine, and that's swapped and dropped already, and barium with carbonate, which is also already dropped and swapped because it's +2 with a -2. Okay, carbonate's a -2, barium's a +2, +1 and -1. Now I got to go back and balance the whole reaction. Putting a 2 there should accomplish all of that. Okay, so it is a little bit tricky when ammonium is involved, especially if ammonium is combined with another polyatomic ion, which it often is. All right, that's how you handle that in that situation. So that one's a little bit tricky. Remember, ammonium always acts as a metal because it's positively charged. Okay. All right, so tomorrow, no quiz. Okay, so you don't have to bother checking tonight, right? But we will be doing the lab. We'll do the pre-lab stuff with the Chromebooks first off, and then we'll go across and perform the lab. It's basically just mix these two things together, record. It's pretty straightforward. Okay, see you guys tomorrow.